Let's consider the following problem. Compute the magnetic field at point P if P is in the same plane as the wire and loop. B. Suppose P is out of the page of position. Compute the field again. I'm going to just do part A basically for this one because that's all I think is really necessary for this problem. All right. So let's consider the following situation. I have this point I moving through this field, and it's basically a source of field basically at point P, and uh, and right. Okay. So what I'm going to do, hold on, this thing is not complete. I see what's happening. All right. So in order to do this, I have to give this thing a certain radii. Right. Let's give it a radius r. So it's not yet complete. All right. And then we're going to go ahead and do this. All right. So in order to do this, we're going to use the law of Biot-Savart. All right. So let's write that down first. dB is equal to mu 0 over 4 pi I dl cross r hat over r squared. All right. Okay. So there's going to be two sources for this B field, right? So it's going to be along these straight segments here. I'll label these segments number 1 and number 2, and then along the loop here, which is number 3. Okay. All right. So let's basically do this first. So the B field is going to be integral over all dBs, which is the integral over basically mu 0 over 4 pi I dl cross r hat over r squared. Okay, and I can break this down into base segments 1, 2, and 3. Okay, so I'm going to break this into base segment 1, mu 0 over 4 pi. Okay, I dl cross r hat over r squared plus segment 2, mu 0 over 4 pi I dl cross r hat over r squared plus basically over segment 3, mu 0 over 4 pi I dl cross r hat over r squared. Okay, so in doing so, right, I'm going to note a few things. So first of all, the I flows along this way. So dl in segment 1 is going to be pointing in this direction. dl in segment 2 is going to be pointing in this direction. And then dl in segment 3 is going to be pointing along this direction. All right, I apologize for the messiness now. Now the second piece is r. R is going to be from the source, which is going to generate the B field, all the way to point of interest. So that's basically R here. That's going to be R there. And this is going to be R here. Okay? So for segment 1 and segment 2, all right, you will notice that DL cross R, these are parallel and anti-parallel of each other. And because of that, basically DL cross R hat, which are two things which are parallel, that's going to be equal to 0. And likewise, they're anti-parallel in this case, so again, this is also going to be equal to 0. Right? Now in this case, they're perpendicular to each other by exactly 90 degrees, so this is actually not going to be equal to 0. In fact, it's going to be equal to dl, right? So the magnitude is going to be equal to dl, right? So this is going to be equal to mu 0 over 4 pi, right? I dl, well, okay, over r squared. Now, I want to get the direction here. This is going to be order unity, so I want to get the direction here for this one. And so I will use my right hand rule here. So take your thumb, point along the DL direction, right? Take R, point your fingers along the R direction. So you can see it's going to point straight into the page, right? It's kind of hard. My hand's very hard to move maneuver that position. So it's going to point straight down. So I'm going to basically take this as the B field going downward. All right. So this is I'm going to call Z-axis, out of page. Right, and this is pointing into the page, so this is going to be basically be in the minus z hat direction. Right, so now I'm left with this integral I have to do basically over segment 3. Right, so fortunately for this, because it's constant r, this r is just capital big R, so it's going to be basically mu 0 over 4 pi I integral of basically dl over r squared in the minus z hat direction. And basically, this is just an integral over a semicircle. It's the circumference of a semicircle, which is half the circumference of a real circle, and the circumference of a real circle is 2 pi times capital R, so this is just pi times R. So it's going to be mu 0 over 4 pi I pi times R over R squared in the minus z hat direction, and then we're done. 1, 2, 1, 2, okay? Mu 0 over 4 I over R in the minus z hat direction. All right, and that's it for problem 1. I'm not going to problem 1A, so I'm not going to do problem 1B because I don't think it's particularly relevant.